Bernstein-Vajrani algorithm. So it is for solving which problem? Bernstein-Vajrani problem. Okay, no, Deutsch algorithm for Deutsch problem, Deutsch-Josa algorithm for Deutsch-Josa problem. It is, sorry, has already discussed all these things. Simon's algorithm for solving Simon's problem. So similarly, this is for Bernstein-Vajrani algorithm. So first we try to understand what is the definition of the problem, formal way of defining the problem. Then we go for the actual algorithm. So yeah, it is similar to the other problems which you have already seen. So input is, what is input? Whatever problems you have studied as part of this, no? What is input? A function f from 0, 1 power n. So this notation is clear, no? What does it mean? All binary strings of length n, okay, to 0, 1. This is input. So we are given a function f 0, 1 power n to 0, 1. Okay. That means it maps all, this function f maps all binary strings of length n to either 0 or 1. Either 0 or 1. What is promise? What is promise? In this case, the promise is there exists a string, yes, there exists a string yes, where we can say s equals to Sn minus 1, Sn minus 2, and so on, S1, S0. That means S is n bit string, there exists n bit string yes, such that f of x equals to x binary dot product s, x binary dot, you are familiar with what is x binary dot product s, no? For every or for all x belongs to 0, 1 power n, for all x belongs to 0, 1 power n. Is it clear what is promise? Okay, we will take an example and then see. So what is the task? What is task? Find s. Okay, find s. Okay, we'll try. We'll see with an example. So let us take n equals to 1. So n equals to 1 means how many bit strings of length 1 possible? 2. So now let us take f is a function. F is a function which maps, okay, 0, 1, because total all bit strings of length 1, 0, 1, it maps to 0 or 1, 0 or 1. Okay. Now here let us suppose that 0 maps to 0, 1 also maps to 0. This is my function f. F is like this. Is that okay? F of 0 is 0 and f of 1 is also 0. That is the meaning, no? F of 0 is 0, f of 1 is also 0. Okay. But we know, according to the definition of the problem, what is the rule it follows to give f of x? It is x dot s. What is the length of s? It is same as x. That means n bit string. If x is n bit string, this is also n bit string. Now, can you try and tell me what is s for this input? Okay. So let me write x can be 0 or 1. These are the two possibilities. Now what is f of x? F of x, we know that it is x into s. In this case, what is x? 0 in 0 binary dot product s. What is s? Because it is single bit normal multiplication and both are same now. What is this? S. What are the options we have? 0 and 1, only two options. No, s is a binary string of length 1, so it should be either 0. Okay, let us try with 0. So we are assuming that whether s is 0 is correct. 0 binary dot product 0. Is it, what is the value? 0. Okay. Now if I take 1 according to x dot s, what is f of x? 1 dot 0. Correct? S equal to 0, is it correct now? Yes. Our goal is to find that s. To find that s. Now instead of this, our function is like this. This is, let us call it as f1. Now can you tell me what is s here? What is s here? 1. So f of x, so s if I take 1, 0 binary dot product 1 0, 1 binary dot product 1 1. Is that correct? Yes, no. Is the definition of problem clear? Okay, let us take n. For example, we have something like this 0 0 0 0 1 1 0 1 1, or f is mapping this to 0 1. Now let us say all are zeros. Can you tell me what is, this is our function f. In this case, can you tell me what is s? It is very easy to find that. Okay. So in this case, s is 0. Why? What? S is 0 or 2 zeros? 0 0, not single 0. No, s is always, length of s is same as length of x. No, so s is 0 0. Why? Because now if you want f of 0 0, what is f of 0 0? 0 0 dot 0 0. What is 0 0 dot 0 0? This 2 we multiply, this 2 we multiply. Correct? No. So it is 0 0 0 XOR this 0. Is that correct? So finally this is 0 XOR 0, this is 0. Is that okay? So similarly you can try now f of 0 1. What is f of 0 1? 0 0 1 0 0. In this case it is 0 dot 0 XOR with 1 dot 0. Is that okay? In general, how does it work? X is xn minus 1, xn minus 2, and so on, x1, x0, n bit string. S is sn minus 1, sn minus 2, and so on, s1, s0. Therefore, what is x dot s? Xn minus 1, sn minus 1, XOR sn minus 2, xn minus 2, sn minus 2, XOR and so on, XOR last x0, s0. This is the way it works. Okay? Or if this XOR, if you have this confusion, then what is that? This is same as xn minus 1, sn minus 1 plus xn minus 2, sn minus 2. This is normal multiplication only, plus and so on, plus x0, s0. For this you take mod 2. Both are same, no? Is that okay? So similarly, what is f of 1 0? Yes, see, because we guessed this, yes, 1 0 0 0. So it is 1 into 0 plus, that intentionally I am writing 1 into 0 plus normal plus 0 into 0. This is 0 only. That okay? Both notations are same. F of 1 1. What is f of 1 1? 1 1. This is, so this can be also written as 1 into 0 plus, this is mod 2, sorry. 0 mod 2, both are same intention, that is 1 0 plus 1 into 0, that is mod 2. So finally this is also 0. Okay. Is the definition clear of problem definition? What is Bernstein-Vajrani problem? Okay. Now I just give you one example. For that you find yes. Then we move on to next step. What is? Example 0 0 0. If such essay doesn't exist, that also you should be able to tell. Okay. Brother? So this is our F, say mapping is like this. What brother? Correct, no. So n equals to 3 I have taken. So total 8 strings, n equal to 3, 0 1 power n. So totally 8 binary strings, no, of length 3. So each one is mapped with either 0 or 1. So I have given some mapping like this. This one, 0 1. Our definition is like that only, no? 0 1. If S exists, you find, otherwise you should be able to tell that no such S exists. I have randomly given this. Okay. If S exists, then you need to find S. What is brute force approach? Try with all possible S's. How many S's are possible? 8. S could be this, or S could be this, or something. So that means what is the condition it has to satisfy? This or X's? No. F of X is X dot S. It should be true for all. Okay, all of you try and find. Okay. So one answer, someone is telling the S is 001. Is this correct or not? We verify. Okay. So for that, what is that we need to do? We check whether f of 0, 0, 0, it is x 0, 0, 0 dot s is saying 0, 0, 1. Is this correct or not? Then what is this 0 into 0, this 0, this 0, XOR this 0, this 0, XOR this 0, this 1. Is that okay? What is this finally? 0. All zeros means directly it is 0. We need not even do that. Okay. This is okay. This 0 is matching. Okay. This is correct. Similarly, we need to try with other 0, 0, 1. So what is our x? 0, 0, 1. This is our x. Dot s is we are thinking 0, 0, 1. What is this value? 0, 0. This is XOR 0 dot 0 XOR 1 dot 1. This is 1. Correct. This is also matching. This 2 over. Similarly, we need to check for 0, 1, 0. What is f of 0, 1, 0? 0, 1, 0 x dot 0, 0, 1. 0, 0, 1. Or now, because only here 1 is there, that means if 1 is here, then it is 1, otherwise the value is 0. No. Is that clear? Directly we can write now. So what is this value? 0. Oh, here this is also matching. Next, f of 0, 1, 1. 0, 1, 1 dot 0, 0, 1. Oh, here 1 there. Why? Because remaining 2s are zeros. Whether 0 or 1, it doesn't matter to us. It results in 0. Only last bit matters. 1 into 1, 1. So this value is 1. 0, 1, 1. Oh, it is mapped with 1. This is also correct. Is that okay? So similarly, you can verify for others. F of 1, 0, 0. 1, 0, 0 dot 0, 0, 1. Here 1, here it is 0. So directly we can write it as 0. We can calculate, but we know the 0. F of 1, 0, 1. What is f of 1, 0, 1? 1, 0, 1 dot 0, 0, 1. So what is this value? 1. Same thing. No? So similarly, f of 1, 1, 0. 1, 1, 0 dot 0, 0, 1. So this is 0. Why? Because this is 1, this is 0. Now what is f of 111? 111 dot 0, 0, 1. Only this one 1. So finally this is 1. I think all are matching. So that means only S is 0, 0, 1 is correct. What is the complexity? So if you are given S equal to 0, 0, 1, verifying is very easy. Now how to find that S equal to 0, 0, 1? In how many possibilities we have? 2 power n. So if at all we are looking for an algorithm which finds S, so if you come up with a brute force algorithm, that brute force algorithm takes how much time? 2 power n possibilities are there. Again, for each possibility, this work we need to do. If you consider it as constant time, what is the total time it takes? 2 power n into constant, that is order of 2 power n or big O of 2 power n time. So brute force algorithm for this problem. Brute force algorithm. It runs in, I am talking about classical algorithm. Brute force algorithm, it runs in big O of 2 power n time. Is that okay? Now the question is there a better brute force algorithm than this? Is it possible to solve it in less than 2 power n time classically? This is trying all possibilities. We know that definitely we get answer, but it takes 2 power n time. If n is large, 2 power n means it is more time. No. Is it possible to do it in less time? Or thank you. In that case, you are close to the answer. So in that case, how much time it takes? No problem, whatever you are saying. So what he is saying is correct, but the same procedure I am going to discuss. So there are total n bits, S contains n bits. So what he is saying is somehow you try to extract bit by bit information. For example, if S is n bit string, Sn minus 1, Sn minus 2 and so on, S1, S0, you do something and find out S0. These are bits, either 0 or 1. This is also bit 0 or 1. So you try to find out each specific bit whether it is 0 or 1. Like that, how many bits are there? N bits. You do something n times, and is it possible to find it that way?
So it becomes n square instead of 2 power n.
Definitely less than 2 power n, no? Yeah. Only n times only. If you do it, then it is n only.
Yeah, 3n.
N only, no? Each bit you are performing one operation to find each bit in S. Total n bits in S. So n operations you perform. Assuming that each operation takes constant time, then it is order of n time. That okay? How to do it? Now try to recall the first example in the tutorial which sir has discussed, where we tried general way. At last sir has given some method with you remember AB equal to C, that the first tutorial problem. We were trying in general way, then sir has given column matrix 1 zeros. Here also something like that we do. Is there any answer? What about other bits? Correct only, you are close to the answer. You are close, almost close to the answer. See, now we wanted to find out S0. How to get S0? We also know that f of x is x into S. X is xn minus 1, xn minus 2, and so on, x1, x0. And x into S is respect to summation we take and XOR we take. Now how to get S0? What is that possibility? Can you tell me? Sir? Remaining, thank you, that's all, that is the answer. Combine whatever you said and sir said, finally that is the procedure. So what we do is, you try with, in this case, if you want to find, here we are asked to find S in this example. We are asked to find S. Okay. For that, what I do is, S is in general, this is S general, this is given X. So what is f of 0, 0? It is given as 0, no? In this case, f of 0, 0 is given. So now you calculate f of 0, 0, 1. What is f of 0, 0, 1? Can you tell me in terms of this S, what is f of 0, 0, 1? Not final answer, in terms of S, this is same as 0, 0, 1 dot S, n equal to 3, S is S2, S1, S0, S2, S1, S0. Now this is nothing but 0 times S2, 0 times S2 XOR 0 times S1 XOR 1 times S0. Is that okay? Now this values, no, whether S2 is 0 or 1, whether it matters? No. S1 is 0 or 1, it doesn't matter. Why? Because result is going to be 0. So finally we end up with S0. But f of 0, 0, 1 value they have already given us, no. Oh, it is 1. It is 1. That means what? This is 1 into S0 actually. This 1 into S0, this has to become 1. This has to become 1. For that, what is the value I need to substitute for S0, you tell me? It has to become 1. 1 into S0 equals to 1. We know that. That's what they have given here. That means, what is the value I need to choose for S0 so that this product becomes 1? 1. Either 0 or 1 we need to take. 0 means it becomes 0, that is contradicting. So 1 only we need to take. That means S0 equals to 1. 1 bit we got no. So therefore, S0 equals to 1. Now out of 3 bits, 1 bit we got. Now you find S1. How do you find? Okay, all of you try and find S1. Yes, S1. Yes. S1 is 0. Anyhow, this answer we have already, but the same procedure here. What is that we get finally? What is that we calculate? 1 into S1, that's all. So in order to find this, we calculate f of, so this is first calculation. Second one is f of 0, 1, 0. Correct? What is f of 0, 1, 0? 0, 1, 0 dot product with S2, S1, S0. Is that okay? So what is that we get? This is same as, because this is 0 means these 2 bits immaterial, no? Whether they are zeros or ones, not going to give us anything. So finally what is that we get? 1 into S1. But what is 0, 1, 0 they have given? Oh, f of 0, 1, 0 they have given as 0. This is 0 they have given, no, f of. This is equal to 0. That means S1 therefore, which implies S1 should be 0. Without trying 8 possibilities, 8 evaluations, with 3 evaluations we can get no. Similarly, what is the next one? What is S2? F of 1, 0, 0 you calculate. What is 1, 0, 0? Binary dot product with S2, S1, S0, which is same as 1 into, these 2 are zeros, these are immaterial, whatever. This is 1 into S2, but what is 1, 0, 0 is given as? 1, 0, 0 is 0, no? 1, 0, 0 they have given as 0. That means what? S2 must be 0, which implies S2 is 0. So finally we have got no same thing. S2, 0, 0, 1. That is the given string, no? Required string, yes. Is that okay? How much time it takes? How many evaluations of that function f? In this case 3. In general n. Because n equal to 3 here, so 3 evaluations. That means what is the running time of this method? N. Assuming that this calculation it takes constant time. This is constant time operation if you assume. Then it is going to, we are evaluating f n times. In this case 3 times. So another classical algorithm whose running time is n, 2 power n to n. Now what is the next question that we can ask? Sir.
But this algorithm will not work every time, right? It is not optimal because if some value, for example, 0, 1, 0 was not defined.
No. This is required input. No, all values for these images are given, no, sir. What is f of 0, 0? That is defined already. 0 or 1 clearly. F of 0, 0, 1 also it is given. Similarly, all 8 it is given. Whether 0 or 1 that is given. That is our required input, no.
So if it was given that 0, 1, 0 is unmapped.
0, 1, 0 is?
Unmapped, it is not mapped only.
That is a promise, no. So we are given a function for which every 0, 1 power n that is mapped with either 0 or 1. So that is the required input, no. There are functions. For example, I only will ask you, if n equals to 2, how many different functions are there? How many different functions are there with the two elements? Both sides two elements. How many? Okay, let me ask the question this way. you have a set this maps 0 1 to 0 1. Okay, now you tell me this is set A, this is set B. How many different functions are there from set A to set B? 2 or more than 2? How many? 4 is correct answer. What are they, sir? So 0, this is one possibility. Now directly I'll write 0 1, 0 to 0, 0 1, 1 to 1. This is another possibility. The other possibility is 0 0 1 0 1, both to 1. This is another possibility. What is the other possibility? 0 1 1 to 0 and 0 to 1, another possibility. Other than this, do you get any other? So there are total 4 functions, no, in this way. Out of this, in this case, we know what is S. What is S in this case? 0. What is S in this case? 1. What is S in this case? Can you tell me S in this case? Zero into 1, 0, no. That means in this case we don't have actually, no. If F is defined like this, do we have F, S, which is satisfying that? Are you getting? See, okay, let me put it. F of 0 is 1, F of this is function F. If our F is defined it this way, is there any S for which F of x is x dot S, it satisfies? Okay, okay, those who are saying 1 for there, so now what is F of 0? 0 in dot 1, this should be 0, but what is that they have given? F of 0 equal to 1 they have given, we are getting 0, it is contradicting, no? What is the other possibility? So we are trying with S equals to 1, you try with S equal to 0. S equal 0, what is F of 0? 0 dot, this is S, this is correct, that means, oh, here also gone, no? That means S is not there at all, no? Input is, we are given a function for which there is some S, for which F of x is x dot S. Function is defined such a way only. Then only we need to find S. So if instead of 2 we have like this, 0 0, 0 1, 1 0, 1 1. How many different functions are there from A to B in this case? How many different functions are there? Now simply think. So 0 0 it can be mapped with either 0 or 1. It has how many possibilities? 2. 0 1 it is independent of this mapping, it may be mapped with either 0 or 1, again 2. 1 0 again 0 or 1, 2. 1 1 0 or 1, 2. Total how many? 2 in, because each one is independent of the other one. By simple product rule, 2 into 2 into 2 into 2 4 times, that is 2 power 4. Which is nothing but 16 functions are there. All 16 functions may not satisfy that, no. Are you any confusion? No, okay. Now if I take 0 0 1 0 0 0 1 like this, total 8, how many functions will be there? 2 power 2, 8. What is that 8? This is how many are there? 2 2 2. Correct? No. Oh, that's all. Okay. So finally, what is Bernstein-Vajrani problem? We are given a function f from 0 1 power n to all n bit strings which map to either 0 or 1, 0 or 1. And what is the promise? There exists a string s such that f of x is x dot product s for every x which is n bit string. What is our goal, our task? Find that s. Is that okay? What is brute force complexity of brute force algorithm? 2 power n, big O of 2 power n. So is there another algorithm, classical algorithm, which is better than brute force? Yes. So that bit by bit we can find no. So we can evaluate f n times for n bit string n times. So each time what are the strings? Only one bit is 1. Second time, first time if you take last bit is 1, next last but one bit is 1, all are zeros. Like that n different varieties are there, different input strings. If you evaluate, automatically we can find f. So that means here how many evaluations of f we are doing? N. Now is it possible to do less than n? See 2 power n to n, another class. Is it possible to do less than n evaluations and find s? That means indirectly, what is lower bound on s? What is the lower bound on now? Number of evaluations of f in classical case. So, like take 2 bits at a time. So minimum for each evaluation gives, because it gives either 0 or 1. No, each evaluation gives only 1 bit. We are forced to do at least n evaluations classically, even if you go for random algorithm also. Correct? No. So classically better than n, is it possible? That is a lower bound, no? Lower bound. So now finally we have order of n time algorithm classically. That is n evaluations of black box function f. Now question is it possible to do it in less than n evaluations? Better than order of n time, that is little o of n time. That's what this Bernstein Vajrani have done by making use of the algorithm which Sir has already explained, that is Deutsch-Josa's algorithm. Only small modification. Calculation is somewhat different. That's all. Is that okay? Now already you are familiar with Deutsch-Josa's algorithm and you know what is Bernstein-Vajrani problem. We make use of the Deutsch-Josa circuit and small modifications and we see how to find actual yes, string, secret string yes. Okay. So Deutsch-Josa circuit, what is in? Do you remember what is the circuit? Okay, all of you try to draw the circuit diagram. That is each evaluation it gives 1 bit of information, new information. So we have n bits. To extract n bits of information, we need n evaluations at least. Yes, sir. Yes, sir. No, it gives only 1 bit of information of s. 1 bit of s, not entire s, no, sir. One evaluation of f, it gives one bit information about s. Yes. Yes, sir. No, that condition is already satisfied given. We are directly finding what is that s. One evaluation, it gives 1 bit of s. So automatically if you get that is it is satisfied, no. Again we need not verify, no. Already you are getting s, the required s. There only n times you are actually cross verification is also happening, no, sir. Based on that only you are getting this s, no, sir. This is Diet-Joseph circuit, no? If you remember? Yes, okay. Now let us, different stages, let us call this as psi 0, ket psi 0, this is ket psi 1, this entire thing here, this stage, ket psi 3, after here this is whatever we are getting now, this we call it a ket psi 4. Oh, sorry, 2, 3 we can. This is 2, this is 3. Okay. No? What does Diet-Joseph algorithm do? What is the problem it solves? Diet-Joseph problem. What is the Diet-Joseph problem? So, okay, no, determining whether given function is constant or balanced. What is the problem is there? It is either constant or balanced. That is given. It is neither constant nor balanced. That type of input is not given. Okay. Okay. Now let us try to. You tell me what is ket psi 0. Same circuit it uses. What is ket psi 0? So ket 0 tensor with ket 0. This is how many times? How many times? N times, no? Here also this is ket 0 n times. This is n times. Next, last one is ket 1. Is that okay? Now, what is ket psi 1? So, hard mod gate we are applying on all n plus 1 qubits. Hard mod on ket 0 tensor with hard mod on ket 0, hard mod on ket 0 tensor with hard mod on ket 1. What is hard mod on ket 0? By 2 or 1 by root 2, sir? So it is 1 by root 2 plus ket 1. 1 by root 2 ket 0. Is that okay? So what is h of ket 1? Because this you used multiple times, no? You have been using almost every class. So what is the other name given to this? This state is called plus state. Sir, use this notation also, no? This is called plus state. What is this? Minus state. Is that okay? So this is 1 by root 2 ket 0 plus 1 by root 2 ket 1 tensor with, okay, same thing we write, last one I am writing. This is for this 1 by root 2 ket 0 plus 1 by root 2 ket 1 tensor with 1 by, okay, this directly I write it as minus state. Is that okay? Is it okay? Now, can you tell me what is this value? Okay, n equal to 2, can you do it and tell me? If n equals to 1, what is that we get? At least can you tell me in this case? If n equal to 1 here, what is the answer we get? What is ket psi 0? Psi 0 is ket 0 tensor with ket 1, no? N equal to 1. Yeah, is that okay? N equal to 1, that is. Now, can you tell me what is ket psi 1 when n equals to 1? h of ket 0 tensor with h of ket 1. Is that okay? What is this? H of ket 0 is 1 by root 2 ket 0 plus ket 1 tensor with ket minus. Is that okay? Is that okay? Correct now? Okay. Now, same thing, n equal to 2 we do, and then we generalize. This is it has been used in Deutsch's algorithm, even other algorithms also has used it. Now, n equals to 2. What is ket psi 0? Ket 0 tensor with ket 0 tensor with ket 1. Is that okay? Now, what is ket psi 1? Ket psi 1 h of ket 0 tensor with h of ket 0 tensor with h of ket 1. Is that okay? What is h of ket 0? We know that 1 by root 2 ket 0 plus ket 1 this is again 1 by root 2 this value ket 0 plus 1 by root 2 ket 1. This is directly, this is ket minus no. Now, can you simplify and tell me what is this? Ah, 1 by root 2 whole square, 1 by root 2 power 2 plus all possible. Thank you, sir. So, if we simplify 1 by root 2 whole square, what is that we get is all possible binary strings of length 2 corresponding kets 0 0 0 1 1 0 1 1. 0 0 means 0 tensor with 0, no, that directly it is written as 0 0. That notation you are familiar, no. Okay. 0 0 means this is 0 tensor 0, no. Okay. In concise form. Okay, last this one as it is, I need to, this I forgot. Okay, thank you. Now, can you tell me n equal to 3, what is that we get directly? N equal to 3, what is psi 1 state? 1 by root 2 whole cube. Here how many terms? 8 terms. N equal to 4, 1 by root 2 whole power 4, 16 terms. Now, you should be able to tell me here now what is that we get? 1 by root 2 whole power n. Ket 0 0 0 0 0, this is n bits. This length is n bits. Okay, no. Plus ket 0 0 0 0 0 0 1, this is also n bits. All are n bits. Next, ket 0 0 0 0 1 0 and so on, plus ket 1. Is that okay? Tensor, this tensor also now I can remove directly, ket minus I can write, no, once you are familiar with that. What are these? We know that, no, what are these? All binary strings of length n. That concise form we can write, no, 1 by root 2 power n. So What is 0, 1 whole power n? What does it denote? All binary strings of length n. Okay. So, because addition, so I will put sigma x belongs to 0, 1 power n. What is that we need to write? Ket x, already ket minus is there. That is all now. Is that okay? So, this is psi 1 state, ket psi 1. Is that okay? Now, next is what is psi 2? Ket psi 2 black box function. This we are applying on ket psi 1, correct now? After applying that black box function, we get ket psi 2. So, what is that value? So, you are familiar with that. No? What does it do? What is the output? What is that we get? Ket. It has been used multiple times. Ket x. This one comes as it is. Next. Y xr x of x. Thank you very much, sir. Okay. So, it is ket x y xr. Okay. This automatically you remember unknowingly after some understanding, after some other. Is that okay? We use that. That's all. No, I can. So, we know that psi 0 is is that okay? Now, I can erase this now. What is psi 2? Okay, so whatever is there, the entire thing is that done. Okay. Now, let me erase this. Now, ket psi 2 is 1 by root 2 power n sigma x belongs to 0, 1 power n this you have already seen, no? And this also you have already seen. If y is minus state, ket x, ket minus, what is this? Oh, thank you, sir. Minus 1 whole power f of x. Do you remember this? Sir has diet just algorithms are used, no? Okay. Now whatever I am, this algorithm, entire thing is based on Diaz-Jose algorithm only, that circuit only. Only f of x we replace with x dot s. After that, small analysis, that's all. So this is same as 1 by root 2 power n sigma 0 1 power n. What is this? Minus 1 whole power f of x ket x ket minus. Is that okay? Now what is psi 3? That's all. That is psi 2 state, no? What is psi 3? What is psi 3? Now x is n bit string, no? Well, now what is psi 3? Can you tell me what is psi 3? What x is actually x0, x is here, x is xn minus 1, xn minus 2, n bit string, no? X is actually like this. Now what is psi 3? What they are saying is you apply hard mod here, here also we need to apply hard mod, here also hard mod, this also hard mod. Okay, now all n. Now what is that? What is the other way of writing that? Thank you very much. H hard mod we are applying how many times? N times. Okay. So it is hard mod like this how many times? N times, because x is n bit string, no. So this is H10, this is the notation we use, no. This notation has already been used, no. Okay. So I write it that way, okay, no, simply 1 by root 2 whole power n sigma x belongs to 0 1 power n. What is this? This one, okay, minus 1 whole power f of x hard mod tensor with n ket x. Not this is not single bit, okay, no. This x it is n bit. It's ket minus. That's all, no? Okay. 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 Now we try to find this value h tensor n ket x. X is arbitrary string, okay, no. X is either 0 1 0 x all zeros means this you have already calculated, no. What is h? This value h tensor 2 ket 0 0. What is this value? 1 by root 2 whole square. 1 by root 2 whole square ket 0 0 plus ket 0 1 plus ket 1 0 plus ket 1 1. What is h tensor 3 with ket 0 0 0 triple 0? All states it puts in equal superposition, no, with 1 by root 2 whole cube, okay, 1 by 8 probability, correct, no? But here x is not 0 0, it is arbitrary value. This x is not all 0 bit string, okay, n bit string with all zeros, not like that. It is arbitrary value. Then what is its value? That's what we calculate now. let us calculate for 1 0, or simply calculate for this is 1, which is same as simply h. We know that this is 1 by root 2 ket 0 plus ket 1. Is that okay? The same thing I can also write it this way, no? 1 by root 2, 1 by root 2. This is say x, this is my x, this is x, okay? 1 by root 2 minus 1 whole power. Okay, let me write next. Here x is 0, x is 0, that means here I replace with 0 with 0. Both are same or not? Oh, get 0, I forgot. This 0 is this 0. This 1 is this 1. What is this 0? It is this whatever is given to us. Is that correct? Similarly, h of ket 1. What is h of ket 1? H of ket 1, we know that it is 1 by root 2 ket 0 minus 1 by root 2 ket 1. The same thing another way also we can write like this, no? 1 by root 2. Can you tell me now similarly? 1 0 ket 0 plus 1 by root 2 1 by root 2 1 by root 2 minus 1, correct? No, this whatever you put here ket 1, that's all. Why? Because here we will get 1 dot 0, this is 0, so that means here we will get positive sign only. Here we will get 1 dot 1, this is 1, this is minus 1 by root 2, correct? No, this is true for, if you want you can try. Okay, only one more we calculate, then we generalize. What is this you calculate? Can you please calculate? H tensor 2 with ket x 0. X is now 1 0. This is that okay? What is this? 1 by root 2 ket 0 minus 1 by root 2 ket 1 tensor with 1 by root 2 ket 0 plus 1 by root 2 ket 1. Is that correct? Now, what is this? 1 by root 2. Now, without using this symbol directly, right? 0 0 ket 0 0 minus plus this and this I am plus 1 by root 2 ket 0 1. Next, sorry 1 by root 2 into 1 by root 2, 1 by root, okay, let me put it this way, okay, 0 1. Now this what is that we get? Minus 1 by root 2 whole square 1 0 ket 1 0. Next, minus 1 by root 2 whole square ket 1 1. The same thing we can write it this way also, no? 1 by root 2 whole square. If there is no confusion, we can take it outside, no? Okay, 1 by root 2 whole square. This form, can you tell me now? Same form, similar to this. Minus 1 whole power. Minus 1 whole power. This x, here see, whatever x is there, this has come here, no? And these are corresponding. Here see, whatever x is there, it has come here, and these are corresponding kets. The is that based on that, can you generally 1 0, this is our x, no? 1 0 dot 0 0 ket 0 0. Is that okay? but here all are plus terms if you see. Okay, now plus minus 1 whole power x is 1 0 dot. Next term we are going to write 0 1 say 0 1 cat 0 1. Is that okay? Plus next term is 1 0 term I am writing minus 1 whole power. This is also 1 0, that is also 1 0. 1 0 dot 1 0 cat 1 0 plus minus 1 whole power. This is 1 0 1 0 dot 1 1 cat 1 1. Now you check whether both are same or not. Can you verify? This step is same as this step. Whether you write it this way or this way, no change. Both are equal. Here, why? This is 1 into 0, 0, 0 into 0, 0. So total plus only I get no here plus term. Here if you see 1 into 0, 0, 0 into 1, 0. So here also this term is plus term. Here if you see here 1 into 1, 1, 0 into 0, 0. That means only 1, 1, minus 1 whole power 1. That means this term is negative, correct? Here if you see 1 into 1, 1, 0 into 1, 0. Again this is also negative. Now we can generalize and tell. Now this, can you tell me what is this value? 1 by root 2 whole power n sigma x belongs to 0 1. Some x is given to us. Okay, now some x is given to us. Okay. Minus 1 whole power f of x as it is. Again we will change this. We know what is f of x also. Okay. Now what is this value? Can you tell me? One more summation. So one more summation, again you take x or some other variable. Other variable, because for x only we are doing. This x is given to us. X of that we are calculating. No. So some other variable you take. But what is that we need to do? 2 times means 1 by root 2 whole square we are getting. 1 time means 1 by root 2 whole power 1 we are getting. In general it is 1 by root 2, 1 by root 2 whole power n. Okay, thank you. Next. Okay, this part we are writing. This part, what is the equivalent that we are writing? Summation. Instead of x we can take y. Y belongs to 0 1. This entire thing again I can write it as simply, this is same as 1 by root 2 whole power 1 sigma x belongs to 0 1 whole power 1 cat x minus 1 whole power minus 1 whole. Okay, here let me put y minus 1 whole power x dot y cat y. Is that okay? Both are same. This is concise way of writing. No, is this correct? Same thing. This is, I am writing it this way. Is that okay? Are any doubt in this step? No, okay. Then you tell me that way here. Similar style, what is that we need to write? 1 by minus 1 whole power x dot y. Okay, thank you. Next, cat y belongs to. Is that okay? After that, cat minus is there, as it is we write. Okay. No? Okay. Now we can do something. Now we know what is f of x. We know that, no? F of x is given as x dot s. F of x. So we know that. I can replace that with that. No. F of x is x dot s. Is that okay? X dot s. Now this is 1 by root 2 whole power n. This is 1 by root 2 whole power n. We can take it outside in a constant. This is 1 by 2 power n. Is that okay? 1 by 2 power n. So what next? Summation sigma x belongs to 0 1 whole power n minus 1 whole power x into s This y also I can, this way also we can, is that correct? Is that okay? Only 1 by root 2 whole power n, that 1 by 2 power n I have written, other thing no change. Now this is a power m into a power n. We know that a power m into a power n is a power m plus n. We know that formula, no. So what is that we can write here by combining these two? So finally x dot s value is what? 0 or 1. X and s are n bit strings, but x dot s is either 0 or 1. Okay. Now what is that we can write? 1 by 2 power n sigma x belongs to 0 1 whole power n sigma y belongs to 0 1 whole power n minus 1 whole power x dot s plus x dot y. Is that okay? No, no, normal addition only, no. No, no. See, a power m into a power n. Normal addition only I have done. Okay, whatever you are expecting, next step I will write that by giving some explanation. I know, okay. Okay. Is this correct or not? Okay. Ket y, ket minus, okay. But this, you wanted this. Okay, no. Why? Because now x, what is x dot s? We know that x dot s is either 0 or 1. Similarly, x dot y is either 0 or 1. These are the possibilities, no. These are the possibilities. Correct, no? In this case, final answer is what? Here we will get plus or minus. We will get plus here, here minus, minus, plus, no. That means these two are same for us. These two are same for us. So this is nothing but minus 1, no. This is, in order to get this plus, minus 1 whole power 0 also gives me minus 1 whole power 2. These two are actually equal, no, sign wise, whatever we are getting, both are equal, no. These two are correct, no. In that case, whether I get to 2 here or 0 here, both are same, no, then I will take XR. Here also answer is same, but I take XR. This also same, then I will take that. Is that okay? Now not required, no sir. This is XR. See, minus 1 whole power this. Is there any confusion here? Okay, no? Now this formula also he knows. Sir has repeated multiple times, know this. This we can write it as x dot s plus y, x dot s plus x, that is distributive law type. So what is that we can write here? Anyhow, we don't need this. Here we can write it as x dot s xr x dot y. Can you write this as x dot s xr y? Is that correct? Okay. This is same as this also, no? Whether we write both are same, no? Value doesn't change, no? Order doesn't matter. Huh? Is that okay? Okay. Now what is simplification that we can do? This we can write it as 1 by 2 power n, same thing, sigma x belongs to 0 1 whole power n, y belongs to 0 1 power n minus 1 whole power is that okay? Okay. So now psi 3 is what? No, we don't need all these things. So what is psi 3? Psi 3 is 1 by 2 power n, psi 3 or psi 2? Psi 3, 1 by 2 power n, sigma x belongs to 0 1 power n, y belongs to 0 1 power n, minus 1 whole power s x or y, ket y, ket minus. Is that okay? Up to this, okay, this I erase now, okay. Okay. Now, what is sigma? So, in order to simplify further, we need some other results. Okay, you please tell me what is sigma x belongs to 0 1 whole square minus 1 whole power x into 0 0. Okay, all of you calculate. Okay, this result we need actually. No. Okay, if you expand automatically, first of all, 0 1 whole square contains how many terms? 4. Okay, now you can. That's all. Correct, no? So which is 0 1 whole square is nothing but what is this? 0 0 0 1 1 0 1 1. This only short form we are writing it this. That's all now. Okay. So what is this? This is nothing but minus 1 whole power x is this. This is 0 0 dot 0 0 plus minus 1 whole power x is this 0 1 dot 0 0 plus minus 1 whole power 1 0 dot 0 0 plus minus 1 whole power 1 1 dot 0 0. We know that if you do with 0 0 dot product, what is that we get? 0 only, no? So minus 1 whole power 0. This is minus 1 whole power 0. What is this? Minus 1 whole power. This also. We know that minus 1 whole power 0 is, which is nothing but 4. What is this for? Cardinality of this set only, no? is okay. Now can you tell me what is sigma x belongs to 0 1 whole power 4 minus 1 whole power x into this, what is this value? 2 power 4. Is that okay? In general, now we use this. Sigma x belongs to 0 1 n minus 1 whole power x dot 0 0 0 0, that is 0 power n, that only short form of writing 0 power n is how much? 2 to the power n. Is that okay? Okay. Now all of you try. Other than 0 0, you take any other string, binary string of length 2. Other than 0 0, you take any string of your choice and complete the calculation and tell me what is the value you are getting. Other than 0 0, anything you can take. Okay, some 0 1 or 1 1 or 1 0, any one among these three you try whichever is your choice, okay, and tell me what is the answer you are getting. Whatever you have taken, you got 0. Okay, let us wait for other answers. Maybe. Zero. So okay. Anyhow, multiple two numbers have given. Whatever you take, definitely you get 0. Why? Because half of the terms, this here no, we get 0. Half of the terms we get 1. Why? Because, for example, if I take 1 1 or okay, 1 0 you take, then what happens? So this we are going to do with 0 0 0 1 1 0 1 1, no, all 4 we need to do, no. Here for example this bit is 1, there are among these there are half strings have 1s here, remaining half have 0s here, no. You take the bit which is 1. Other bits you don't forget. Here it is only 2. In here there are, this bit is 1. Here MSB, here 1 1. There are 2 which for which last bit is 1, 2 for which last bit is 0, no, exactly half. This is 2, total is 2 power 4. This is 2 power 4 by 2. This is also number is 2 power 4 by 2. That is nothing but, you know, this is sorry 2 square by 2. Okay, no? 2 square by 2. Whatever answers we get here, here it is plus 1. What can we say about this value? 0. This is 1 means this is 0. Similarly, this whatever answer we get here, this will be opposite answer. No, why? Because this bit is changed. That means that's why they get cancelled each other. Finally, what is the answer we get? 0. So, if x is 0, 0, in this case answer is 2 square. In all other cases, if x is not equal to 0, 0, what is the answer we get here? 0. Is that okay? So, here now write one more result. What is sigma x belongs to 0, 1 n minus 1 whole power x dot x dot s say are where equal to 0 if s is not equals to 0 power n. Is this okay? Okay, and if you are confused with this, you put r is not equals to 0 power n. Is that okay? X belongs to 0, 1 whole power n minus 1 whole power x binary dot product with r is 0 if r is not equal to all zeros, that is n bit strings. Is that okay? Now, can you tell me what is x belongs to 0, 1 n minus 1 whole power x dot 0 power n? 0 n means 0 n times. Okay, no. What is that value? 2 to the power n. X dot something which is different from this, anything whatever you write here, r where r is not equal to 0 power n, this value is 0. That's what, that is our whatever I have written that. No, okay. Now using this we can simplify further. What is that? Now you look at psi 3. So same thing, no need to write out. Now simplify that psi 3. Repetition. That step is there. Okay, not required. Now tell me psi 3. Any further simplification? Psi 3. 1 by 2 power n. 1 by 2 power n. Sigma x belongs to 0, 1 power n, x belongs to 0, 1 power n minus 1 whole power sigma y belongs to 0, 1 power n minus 1 whole power x plus ket y ket minus. Okay, this is the one we have now. Now here, if this value is 0, that is 0 power n. All x is binary string of length n. No, if s plus y is equal to 0, anyhow this step is here similar, something like this. This part is all zeros. What is that we get? What is that we get? When do we get this as 0? S equals to y. Thank you very much. We are almost done now. So if s equals S XOR Y, S XOR Y. If S equals to Y, that means what? S equal to Y. So what does it mean? In that case, there are two possibilities. No. Okay, let me write separately. S plus Y, it is 0, or S equal to X is 0. Display 1 or X equals to 0 power n, X not equals to 0 power n. These are the possibilities, no? These are the possibilities. Okay. So now X equals to 0 power n. How many cases we get X equals to 0 power n? Only one case, no? All remaining 2 power n minus, how many x's are there? 2 power n x's. Out of 2 power n x's, only 1 x, all x, bits are 0. Remaining 2 power n minus 1 x's, at least 1 1. It is non-zero. Okay, no? Non-zero. So let me separate this. Okay, 1 by 2 power n, x belongs to 0 1 whole power n. We can write 1 by 2 power n into sigma y belongs to 0 1 whole power n minus 1 whole power 0 power n. X equal to 0 power n case separately I am writing, remaining all cases separately. Okay, this case I am writing now. Okay, this case 0 power n into S plus X or Y. Is that okay? Ket Y, ket minus. This, no? This is one possibility. So what are other possibilities? In all other cases, what is that we get? 2 power n sigma y belongs to 0 1 power n minus 1 whole power something which is not equals to 0 power n S plus y ket minus, no? But like these terms, how many such terms will be there? Like this we will have 2 power n minus 1 terms we have. This also it is, or you can consider this as x equals to 0 0 0 0 0, last one is 1. This is x equals to 0 0 0 0, all are zeros. The next one is 0 0 1 0. Next, are you getting? Last one is x equal to all ones. Is this clear or why? Okay. This equals to 1 by 2 power n sigma y belongs to 0 1 whole power n minus 1 whole power. This is nothing but all ones, let us say, let all ones into S plus y ket minus. Is that okay? Now we know that all these terms value is how much? 0. Why? Because this we know, no. All are zeros. How many times you add, we are going to get 0. So finally, here only it matters. Here what is that we get? What is that we get? What is this value? What is this? What is that we get? Here, what is this value? Okay. Okay. This I can erase now. I think this part not required. So finally, side 3. Anyhow, this we are not measuring last. This no need to write remaining here whatever minus we get. No. Initially itself we can ignore that. That's not a. Okay. So finally, this we can write it as 1 by 2 power n. 1 by 2 power n. Sigma minus 1 by 2 power n sigma y belongs to 0 1 whole power n. This entire thing is 0 only, no? So x or y, correct now? Minus 1 whole power n 1 by 2 power n. I think something I missed. One second. X dot s or y, that is correct. Y is also there. Okay, just a second. Okay, now we can even do this. SXR 0 power n. This is, oh sorry. When did this s equals to y becomes s? When does s becomes y? This minus 1 whole power n, this is 0 power n s y minus my 1 second. This is 2 power n, this is okay. X dot s plus y, this is also okay. This is y, this is minus. Okay, let me do it again. 1 second. This part is okay. No, when do we get 0? When do we get 1? Okay. Yeah, what's that saying something? Yeah, okay, I think with that we can easily complete what you said. That is simple. Okay, correct. So that is psi 3 1 by 2 power n 1 by 2 power n sigma x belongs to 0 1 power n 0 1 power n sigma y this step no 0 1 power n minus 1 whole power x dot s plus y. This anyhow not required. So here there are two possibilities we can take this way. Yes. In this case, what does it mean? S equals to y, no? That is 0 power n, sorry. Okay. So in this case, S becomes y. Here we will get S. That is our required string. No, with probability 1 we get S. That's all. That is last step. Are you getting? So in this case, in all other cases we have seen no, the terms get cancelled and that zeros only we get. Only S equals to y. In that case, that is our required S with probability. That means that is the secret string S. Are you? That's all. That is the algorithm. That with the probability 1 we get that y equal to S. That is only our S, no. So here how many times we evaluated that BF? Only one time, not n times, no. Only one time where here only this place we use, no. Only one time. Only one time. Is that okay? So here 2 minutes I quick review of what we discussed. So what is Bernstein-Vajrani problem? So if we are given a function f 0 1 power n to 0 1 0 1. So all binary strings of length n to either 0 maps to either 0 or 1. What is our goal? What is our promise? There exists some string s such that f of x equal to x dot s. There exists some string s such that f of x is x dot s, such that what? That is true for all x belongs to 0 1 power n, all n bit strings. Okay. Now what is our goal? Find s. Find s. What is classical way of doing? What is brute force algorithm? Try all possibilities. How many possibilities we have? If x is n bit string, s is also n bit string. So how many possibilities total? 2 power n possibilities. It takes 2 power n time at least. Okay, no. If operations, if you take constant time, then it takes 2 power n time. So that is big O of 2 power n we can say. But by using the other method where you make only out of n bits only 1 bit 1, so that 1 bit of secret string s we can find by evaluating on f. Okay, like that n times if we do all n bits of f, n bits of s we can find, no. But how much time it is taking? N evaluations of f, order of n time. And in fact that is lower bound also, less than that it's not possible. That has been shown. Why? Because one evaluation gives only 1 bit of information about s, so n evaluations are required in factness. That is big omega of n type. Okay. Now later this, by making use of this Deutsch-Josa algorithm, Bernstein-Vajrani have shown that okay, with one evaluation of block box function f, okay, that is bf, Okay, we can find out that secret string yes, that secret string yes. So the circuit is same circuit. What is this circuit? Di-Josa circuit. Okay, no, this is n bit string, so n zeros. What for this? This part is a common. No, you have seen almost all circuits. No, what for this? To put all states in equal superposition. All n bit strings. No, these are qubits. These are all on n bit equal superposition. Then after that they apply this. Now what is psi 0 state? 0, ket 0, tensor, ket 0, ket tensor, all these things, n times 0 power n, tensor with ket 1, tensor with ket 1. So what is psi 1? You apply hard mod on each of these qubits, 0 or 1, then what is that we get? It puts all the states in equal superposition with the probability 1 by 2 power n, not root. Probability is 1 by 2 power n. H of 1 is ket minus that we have written. Okay. Next, after that, what is our second step? Now we are going to apply that gate, that BF. Okay. BF of ket psi 1. BF of ket psi 1. So what is that we get here? X minus, if this is input special case, we will get this minus 1 whole power f of x ket x ket minus. So with that, what is our psi 3? What is our psi 3? What is our what is our psi 2? Can you tell me what is psi 2? What is psi 2? What is psi 2? 1 by root 2 whole power n, 1 by root 2 whole power n, sigma x belongs to 0, 1 power n, ket x ket minus. What is this value? 1 by root 2 whole power n, sigma x belongs to 0, 1 power n, minus 1 whole power f of x ket x ket minus. Correct, no? That is psi 2. After that, what is that we have done? We know that f of x is x dot s, that we substituted there. What is the other thing that we know? Anyhow, this f of x we can replace with x dot s. After that, psi 3. After that, psi 3. So for that, we need to apply hard mod gate. And after applying this hard mod gate on this, what is the answer we get? Arbitrary x, ket x. What is that we get? 1 by root 2 whole power n. It is not written. Oh, I think not written. 1 by root 2 whole power n. 1 by root 2 whole power n. Sigma y belongs to 0, 1 power n minus 1 whole power. This is x, no. X y ket y. We made use of this result. Okay, now after substituting that, and f of x is x dot s, f of x is x dot s, we got this. After that, what is final step? What is final step? Yes, that x or y, that is 0 power n. The other case is not 0 power n. If that is 0 power n, all terms become minus 1 whole power 0. That means what does it mean? What does it mean? Total 2 power n terms are there, that we get it as 1 by 2 power n into 2 power n terms, and that happens when s equals to y, if and only if s equals to y, both sides. Okay, no, if and only if s equals to y, and in that case y you replace with s, that is our required secret string s. With one evaluation we are able to find that secret string s. Is there any? So those who had some confusion, you might have confusion. Here 2 summations are there, number of terms are more. Though 2 summations are there, what happens? Here s xr y 0 power n, s xr y not equal to 0 power n. Okay, no. In that case, all 2 power n minus 1 times they cancel, they give final value 0. So, other term only, that term only remains where y x s is same as y. Is that okay? And that's all. Okay. X 0 power n, instead of that the s plus s x r y is 0 power n. That is the only final step. So, any doubt in this? That's all. It is almost like whatever you learnt in Joseph's thing, we are making use of that, and a small simplification bit different. You have already learnt h odd mod n all 0 ket 0 0 0, that here we have done h odd mod n ket x. What is the formula? That like that 3-4 formulas we used. That's all. Okay, that's all. Okay. Okay, it's time also. Okay, thank you then. Okay, so afternoon we will have tutorial session. Okay, which will be useful for your some assessment test is there. No, that is on Thursday. It is planned on Thursday. We will solve some problems related to whatever we discussed so far. Maybe at least initial some topics will have some session, and Thursday or Wednesday afternoon also one session is planned. No, not Wednesday, Tuesday afternoon I think. Tuesday afternoon also we have tutorial session, or 2 hours tutorial session is there in the schedule. Okay, as per the schedule. This two, it is only for you to write that exam. Okay, without any difficulty. Okay, thank you then. We will go for lunch. Okay, welcome back to the session. Okay, this session we are going to discuss some problems based on whatever 5.5 days or 6 days we have discussed. Yes. Okay, sir. Is that clear? Okay. So the first one, we are given a complex number 4 plus 4i. Determine the magnitude. What is magnitude of that? What magnitude of a plus ib? Square root of? Is that correct? So from that we know that it is square root of 4 square plus 4 square, it is square root of 32. Okay. What is phase? Tan, thank you very much. Tan inverse of b by a. So tan inverse of a plus ib phase is tan inverse of b by a. So it is tan inverse of 4 by 4. So tan inverse of 1, what is this? 45 or pi by 4 radians. Is that okay? What is polar form? You might have heard, no? What is polar form of that given complex number? What is it? What is square root of 32? Magnitude e power I theta. Theta is phase here. R into e power I theta, where R is magnitude. Is that correct? Those who opened any textbook, you might have come across these things, no? Okay. Otherwise, square root of e power I times theta, where theta is tan inverse b by a. Is that okay? Because again different quadrants it changes. Okay, I have taken both positive, so it is straightforward. Is that okay? So final form is square root of 32 e power I pi by 4. Achha, sorry. Cos theta plus I sin theta. Okay, this is next question, next part. Exponential. This polar form is cos theta plus cos pi by 4 plus I sin pi by 4. Okay. That okay? Okay. Now what is second one? What is the answer for that? You get a scalar or matrix? That you tell me. That is enough. Man, what is the order of resultant matrix? Matrix are so it is 3 by 1. The other one is 2 by 1. What does it mean? It is but this is Bros I know. So that is 2 by 1, 1 by 2 it becomes. So finally what is the answer? What is correct? Two, 4, 5. So what is Bros I? 6, 8. This is a normal matrix multiplication. Okay. 3 by 2, 3 by 1, 1 by 2. Resultant is 3 by 2. So 2 into 6, 2 into 8, 4 into 6, 4 into 8, 5 into 6, 5 into 8. Is that okay? Only Bros I out to one is column vector, the other one is row vector. You come across all these things. No, instead of the 0, 1, 1, 0 we get. Okay. State true or false and justify. Okay. Is it a valid quantum state or not? Third one. So L2 norm should be 1. Or Euclidean norm is what is the value? Is it a valid qubit state or not? valid. How much we get? So first one is a plus ib. Okay, it is 4 by 5 plus minus 1 by 5, something like this I can write now. Okay, this is get 0 plus this is third one plus 2 by 5 plus 2 by 5 I get 1. Is it a valid? This is valid state or not? So for that, what is that we need to check? Correct? No. So this is 16 by 25, 4 by 5 whole square. Okay, 16 by 25. This is 1 by 25. This square root. Here we get 4 by 25. This is also 4 by 25. Overall, if you take, it is 25 by 25. 25 over 25. It is 1. Oh, that is L2 norm is 1. Hence, it is a valid state. What about fourth one? This also sir has explained. No, what is unitary? When do you say that a square matrix is unitary? U times U dagger equal to U dagger times U equals to identity matrix. Okay. Now that is given in exponential form. No, e power I theta. What is e power I theta? Cos theta plus I sin theta. Okay, can all of you do it and verify whether it is right or wrong? Given matrix, let us call this as U 1 0 0 cos theta plus I sin theta. What is U dagger? What is U dagger? Conjugate transpose we need to take now. Okay. So, what can you tell me what is U dagger? What is transpose of this? 1 0 0 cos theta plus I sin theta. This is transpose, but conjugate transpose no. Conjugate transpose. What is conjugate transpose of real number? No change. No change. No change. Oh, this it changes. A plus IB is A minus IB. No, that's all. Now normal multiplication only. You multiply and check. That's all. If you multiply U times U dagger, what is that we get? 1 0 0 cos theta plus I sin theta. We know that cos square theta plus sin square theta is that's all. That formula if you know, then automatically you can. So here 1 into 1 1, 0 into 0 0. So 1 into 0 0, 0 times 0 0, 0 times 1 0, this times 0 0, 0 times 0 0. This is cos theta plus I sin theta into cos theta minus I sin theta, which is nothing but cos square theta plus sin square theta, but we know that it is 1. Cos square theta plus sin square theta, which is nothing but 1. Which is nothing but 1. Hence, it is a unitary matrix, no? Okay. Similarly, the other side. Sir? Somehow we need to show, that's all. This is one way I have shown. The normal multiplication only, no, sir. Okay. Similarly, U dagger times U equal to I, that you can show. Okay. So now fifth one. So we are given some simple quantum circuit. Okay, all of you do it and tell me what is the answer. Any answers? Okay. So, one way is, what is T1? Hadamard on whatever T naught we have now, state at T naught, state at T1, that is say ket psi 1, state at Ti is ket psi I, then what is T1 ket psi 0? We know that that is 2 minus 2i by 3 ket 0 plus 1 by 3 ket 1. Again we need to do with h, again we need to do with x. Instead of that, what is the other easy option? So now what is the order in which we applied the operations? First to Hadamard, after that again Hadamard, this is first one, this is second one, next x, this is third one. No, for this we are applying what is that, whatever it may be. Okay. In general we can try with alpha ket 0 plus beta ket 1, it is something like that form now, alpha ket 0 beta. Now what is the unitary matrix corresponding to this? This is nothing but product of these three corresponding unitary matrices. No, we know what is x. What is x? 1 0. We also know what is matrix corresponding to Hadamard matrix. It is 1 by root 2 1 1 1 minus 1. You multiply. Okay, no. Sir? Okay. So only the procedure I am telling. Okay, no. So multiply, then what is that we get? You can 0 1 1 0, 1 by root 2 1 1 1 minus 1, 1 by root 2 1 1 1 minus 1, whatever value. Anyone has completed, you can tell me. What is the answer? Zero? This entire after multiplying, have you done? Anyone has done? Otherwise you can do it. At least 2 members same answer. Okay, in that case, if this is identity, this will be the answer now. That means finally it is applying x gate only, performing x operation. That is nothing but identity. That is identity. What is saying is, this product, if you calculate, this will be 1 0 0 1. Okay. So what is this? Anything with identity matrix, we will get 0 1 1 0, 0 1 1 0. Now finally what is that we need to calculate? Okay, 0 1 1 0, 0 1 1 0 with alpha ket 0 beta ket 1. What is that? The corresponding column matrix? 2 minus 2. This is alpha and this is beta. Then what is that we get? Simply we can say alpha beta get alpha times ket 1 plus beta times ket 0 we get. No, then we know what is the final state. It is 2 minus 2i 1 by 3 times ket 0 plus 2 minus 2i by 3 times ket 1. That is final state. T3. T3 we get that. Same thing, measurement means what is that we get? What is the probability of getting 0? What is probability of getting 0? It is 1 by 9. What is probability of getting 1? Total probability without calculating also you can tell, okay, it is 8 by 9. Is that okay? Any doubt in? Only thing is reverse order we need to apply. 6a, all quantum operations are reversible. Earlier someone has asked some doubt, okay, no, whether AND gate we have equivalent to quantum gate. I remember one participant has asked this question. NOT gate, classical NOT, the corresponding we have no. Similarly, C NOT, control NOT gate also we have, but this AND gate, is it AND operation? What is AND operation? We remember, no? Input is okay. Whether do you have corresponding, is it a quantum gate? No. Why? Is there a unitary matrix which converts this to the corresponding outputs? No. Why? All operations are reversible operations there. Okay, no. Here, if I tell that final answer is final output is 0, can you uniquely determine what are the corresponding inputs? It could be 0 1 also, it could be 0 0 also, it could be 1 0 also, no. But same thing if you take C naught. C naught, control NOT gate. Here it is. This is input. 0 0, what is that we get? 0 1 1 0 1 1 0 1 0 1 1 0. Is that correct? This is control, this is target. First one is control, target. Is it reversible operation? Yes. If I tell that this is 1 1, you can uniquely determine that the corresponding input is, okay, the first bit, this is same, no, this same as this, and it is opposite, okay, no, flipped. Is that okay? All quantum operations are unitary. That means that is true. Okay. What about B? The following quantum circuits outputs 0 with probability of. What is matrix corresponding to I? 0 minus I 0. That's all. 0 minus I 0. Then what is that we need to do? That you multiply with 0 minus I 0. What is ket 1? 0 1. What is that we get? I times 0 0. This is minus ket 0. But what is given there? Something else is given. Okay. Probability 1 by 2. So what is the probability with which we get 0? 1. 1 by 2 is not correct. Okay, okay. What about C? All of you agree C equal to bra 1 is what? 0 1. That is row vector. 0 1. 0 1 0 1. C 0 1, ket 1 is 0 1. So are we going to get a scalar or a matrix? 1 by 2 and 2 by 1. Are you going to get a scalar or a matrix? Scalar. What is that? 1. So here, okay, that means it is true. It is true. What about D? Is it true or not? Yep. 1 square plus 1 square plus 1 plus 4 or 4 plus 1 1. Total it is root 11 only, no. Okay. What about E? That is true. D is true. What about E bit? What does a computational basis for 3-dimensional vector space? What does it mean? What does it mean? That means so for example, if I give you 6, 7, 8 column vector like this 6, 7, 8, is it possible to represent it using the set of vectors, these 3 column vectors 1 0 0 0 1 0 0 0 1 as a linear combination? How do you do that? 6 times 1 0 0 plus 7 times 0 1 0 plus 8 times 0 0 1. Is that okay? So that means any column vector of whose order is 3. 3 means that is it contains 3 rows and 1 column. That we can represent using linear combination of this. Any column vector of dimension 3. That means 3 rows with 3 rows. Are there any column vectors with 3 elements or 3 rows which do not which is impossible to represent as a combination of this? No. Then we say that that is so 2-dimensional we have been using. No, what is that is called standard basis. No, what is that? 0 1 1 0 2 comma 5 we can represent anything we can represent using 0 1 1 0 at the 2 matrices. No. Okay. Quantum teleportation protocol contradicts the no cloning theorem. False. All of you agree? Why it is false? Same thing we are sending to other side. No, then false is correct answer. I agree. Initials. Because no, that vanishes on the receiver side. We have that. Okay. What about G? Finally, that is contradicts no cloning theorem. True or false? False. What about G? Morning also we did something similar to that. No. We have that is G. No. G. This we have done already. Ket x. What is this? 1 by root 2 whole power n. What is this value? 1 by root 2 whole power n. Sigma y belongs to 0 1 n power n minus 1 whole power y ket y. Is that okay? Now same thing, instead of x and x they have given some different value, n also 2. Now you substitute and tell. That is binary dot product. So substitute x is 1 0, n is 2. N is 2, no? Then what is h tensor 2 of 1 0? It is 1 by root 2 whole square. Sigma y belongs to 0 1 square. Okay, directly we can write now. Minus 1 whole power x is 1 0 dot product with 0 0 ket 0 plus minus 1 whole power 1 0 0 1 ket 0 1 plus minus 1 whole power 1 0 1 0 ket 1 0 plus minus 1 whole power 1 1 dot 1 0 ket 1 1. Correct, no? Is that okay? So anyhow 2 are zeros, this is going to be positive. Here 1 and this is also positive. here 1 1, so this is negative, okay, no, here also 1 1, these two are negative, here they have given different, no, is that okay? Okay. So what is 2 to 1 function? You know, all of you know what is 1 to 1 function, no? What is 2 to 1 function? Those who open any textbook or something related to Simon problem, you might have read this also, okay, no? But I am asking, is it true or false? Something like this. Here I have 4, here 2 elements. No, set A has 4 elements, set B has 2 elements. Is it a function first of all? It is a function. Is it 1 to 1? No, it is not 1 to 1. Now, is it 2 to 1 function or not? 2 to 1 means exactly 2 elements of A, they have same image. X1 belongs to A, X2 belongs to A, f of X1 equals to f of X2 for X1 and X2 only. There. Now, whatever function is given, is it 2 to 1 function or not? 2 to 1 function. Now, if I put it something like this, is it 2 to 1? No, that is not 2 to 1. If a function is from A to B and it is 2 to 1 function, it is a 2 to 1 function. Which is? No. Every element will have only one image, no. Only two elements, one same, the image is same. Okay. Here, if you observe here, what are these values? It doesn't matter to us. This length, all those things, it doesn't matter to us, no. Okay. Now, what is given? Now, you tell me, is it a 2 to 1 function or not? Okay, 0 0 0, that is 4 ones, 1 0 0 4 ones. Okay, next 0 0 1, 1 1 0 0. Anyhow, you saw that is total 4 pairs we are able to make. Hence, it is a 2 to 1 function. Anyhow, you come across that once you open any. Now, you remember now what is Simon's problem? Okay, no. There is a function G 017. 017 means you know what is the meaning? All binary strings of length, bit strings of length 7 to 01 power 4. Okay, first of all, how many functions are, how many G's are possible of that type? This is anything 01 power 7. This side we have 01 power 4. A to B. Set A, set B. Okay. How how many functions are there? Okay, first we calculate that, then we can talk about Simon's problem. Total how many elements? What is the cardinality of A? Set A? What is cardinality of set A? How many elements are there in set A? 2 power 7. How many elements are there in set B? 2 power 4. Okay. Now, okay, no, yeah, this is say A1, A2, A2 power 7. Okay, these are the elements of set A. This element can be mapped with any element of B, no? How many B's we have? B1, B2 and so on, B2 power 4. Okay, let us label them like that. This can be mapped with any of these 4. That means there are 4 possibilities for this. What about A2? It is independent of A1. No, A2 also can be mapped with any of these 4. Similarly, A2 power 7, it can be mapped with any of these 4. Now you can calculate. No. Okay, I'll come back to that. Okay. Simon's, we are not finding answer for that. How many functions are there of this type first? For any function, no, that's what we are asking. No. Okay, how many are there? 4 into 4 into 4, like that, how many times? 2 power 7 times. Correct? No? Okay, that many functions are there. Okay, leave it. Now the question is, there is a function among this, at least one function is there. Among this many functions, at least one function is there which satisfies Simon's promise. That's what they are asking. No, question is that. For Simon's promise, what is the condition? What is cardinality of B? What should be the cardinality of B? What is cardinality of B? Cardinality of B, it should be at least half of this, half of cardinality A, greater than or equal to cardinality of A. Okay, no, then only that promise is whole. That means 0 1 power 4, that is at least half means not correct. No, 2 power 7 by 2 means 2 power 6. It is not possible. No, not even one function is there among all these functions which satisfies Simon's promise. Is that okay? I think again you read the problem definition one more time. There is function G 0172 0144 which satisfies the Simon's promise. Okay, you open what is all of you read problem definition Simon's problem. Okay, I only will display. I have slides now. Simon's problem. You read this and you only tell me. Okay. This definition, no, this is okay, special case, but what is the condition it has promised it has to satisfy? You see that f of x equals to f of y, if and only if x or y equal to s, that condition should be satisfied. That means what? For every 2 elements, one different element must be there in the range that set to be. Total how many we have? 2 power 7. For every 2 elements, one different element should be there. 2 power 7 by 2. That means at least 2 power 6 elements should be there. Otherwise, this condition is not satisfied. 2 power 4 means how is it possible? Not possible, no. It is. Maybe I think not clear. 2 power 7 by 2 is 2 power 6, no. Okay. 2 power 7 by 2, we can write it as 2 power 7 minus, this is 2 power 1, no. A power m by a power n is a power m minus n. A power m by a power n is a power m minus n. This formula, that is 2 power 7 minus 1. Okay, now. Is there any doubt in this? Okay. Okay. This you only should answer. Okay, you have been using it multiple times. Please, all of you draw circuit. Done. Done. That's all. Correct. Can you go on there simply? No problem. No. Sorry. That's all. Oh, okay, it doesn't matter. This is also okay. This is that's all. That's all. Then okay. This is okay, but this is not okay. Adamad is single qubit gate. No. That is okay. Can you explain, brother, why?
So by applying Hadamard on, we only all of the states which are provided here is.
So can you give qubit final state?
If the state is psi, we can write it as.
That's all, brother. That's all. But it is here if you use like this, it is only 1 qubit you get now finally. But we need it is 3 qubits, no madam. If you apply like okay, this is correct only. Okay. Then you put simply H3 here. That is enough. Okay. Because you don't get, this is 2 by 2 matrix, 2 by 2, 2 by 2. If I multiply 3 2 by 2 matrices, 2 by 2 only I get, but this is 8 by 8, no. Okay. One below the other, not higher. Correct, no? Okay, thank you very much. Is there any doubt, whatever he has written? So this is plus state output, this is plus state here. So again this is tensor product of that we take 1 by root 2 ket 0 plus 1 by root 2 ket 1 tensored with 1 by root 2 ket 0 plus 1 by root 2 ket 1. Again tensored with 1 by root 2 ket 0, 1 by root 2 ket 1. It gives 1 by root 2 whole cube ket 0 0. Is that okay? Now tell what is the probability of getting 0 0 1? One by root 2? probability 1 by 8, 1 by 8. Okay, this you are given two simple circuits, whether they are equal or not. Here for the given input we are verifying whether they are going to give the same final state or not. That is meaning of equivalent here. Okay, no, it's not that for arbitrary qubit. All of you have done. Only thing is the first one, what is unitary matrix corresponding to that? First circuit. First we need to apply X or H. This is the unitary matrix corresponding to first circuit. Then whatever we get here, this product that we multiply with 1 0. Correct, no? In second case, it is first we are applying performing X operation, next H no. So it is Hx 0 1. That's all. Okay, no? Proceed. Okay. Okay. Ninth one. What? So they are going to give the same state, no? Final state is same, no? State is same, no? What is that we get? Okay, you can do it if you 0 1 1 0 1 by root 2 1 1 1 minus 1. This you multiply. What is that we get? 0 1 0 minus 1 1 1. Correct, no? This part is over. Now this entire thing you multiply with 1 by root 2 1 minus 1. This is xh. Multiply with 1 minus 1 1 1. What is that we get? With 1 0 1 again 1. This is nothing but plus state, no? 1 by root 2 get 0 plus 1 by root 2 get 1. Okay, those who have difficulty, we can write this as 1 by root 2 times 1 0 plus 1 by root 2 times 0 1. Both are same, no? This and this. We know that 1 0 is nothing but get 0. 0 1 is nothing but get 1, no? Which is also called as plus state. The other one also, I think those who have done it, you got same, no? Same or different? Same. Okay, now all of you try to do using whatever operations you know. You know X operation, hard mod operation, Y also, even Z operation also you must be knowing. This already you should know, that is Bell state. So clue also there in the question itself. You are as of done. Okay, good. That's all. So others also, please. That is there in the whatever circuit Sari has discussed. No. Which one? Which protocol? Super dense coherence protocol also, quantum. In this teleportation also we have that. No, we start with. Done. Yes, sir. Yes.
Yeah, with respect to this question 8, okay, so here, the way the question is posed, the question is, so there are two ways in which we asked about equivalence of circuit, okay? So here, the question is asking about the equivalence of actually state that ends at the end of the circuit, okay? Now, sometimes when the equivalence of circuits will be asked, what it should mean is that the unitary operation performed by that circuit is the same. That is, it will be, for every input, they should give the same answer. Okay? So sometimes the question can be posed like that. If you have any ambiguity in your mind, you should first clarify. Okay, are we talking about the equivalence of the state or equivalence of the circuit as unitary operation? Okay? In which case, so now tell me one thing. Take the same circuit but remove the input as 0 and 1, okay? Okay? And forget even the measurement part. It's just the unitary part. HX, XH. Are they equivalent? Can somebody answer that one?
Okay.
Yes, please. Can somebody answer that one?
Half is done, other part you can do.
Yes.
That also written. XH is done, HX you do that, sir. No. No, the difference clear, no, what sir has. So sometimes that's why I repeated, no, for the this input final state is same or not, you verify. But in general, the final unitary operation is same, means irrespective of any input we get the same thing, no. That is more general, okay. Now X
No. Is it correct, this one? No, the multiplication is correct, is it?
Oh, okay, 1 0 1 1 is correct, 1 is correct, okay sir, 1 is correct, -1.
You see the minus one?
No, I think 1 0 -1 1 0.
Then you can see the minus is in different places, right? 1 minus 1 1 1 1 1 minus 1 1. So as such, as a unitary, they are not the same. This is very important for us to note, because even if h followed by x and x followed by h, the same gates, but the order matters. They are not commuting in general. So in this case, the circuits are not. But I'll tell you now, I don't know, because we want to continue on that one, but just a little different. Okay. Okay, I think this is given as one of the tutorial questions, but we didn't have time to do it, okay? So this circuit, Okay? We try to show that this is equivalent to I think it is like this. Let me just double check 1 minute. Huh? Basically,
Okay, at least you can try know whether you can verify whether both are equivalent or not.
in this circuit, the control not like this. Control on the first wire, not on the second wire. Here is the control not reverse. Control on the second wire, not on the first wire. But now there are harder. Now you have to show that these two circuits are equivalent. Okay? So one way is that you try to form the whole unitary. Okay? But that might be a little bit complicated calculation because so many unitaries are there. That. Another can be you show that for all basis states. Remember, we're always saying in order to determine the action of a unitary, we just determine the action on a basis states. Correct? So, here is the circuit 1, here is the circuit 2, right? Circuit 1, what is the action on basis states? You see. Okay, 0, 0, 0, 1, 1, 0, 1, 1. Where they go? Circuit 2, you see the action. Okay? Zero, 0, 0, 1, 1, 0, 1, 1. Where they go? If this is the same as this, then you can say they're equivalent. Okay? So, you try to do that. Okay? Same. You already saw. Very quick. Huh? Good. Maybe you can try to show here. Or you just multiply everything. Huh? Sorry, what? What? Okay, you show. How you show? Yeah. You come. Huh? Okay. You try this one. I don't know, but maybe you want to continue with other questions.
Now we'll give break for 5 minutes or 10 minutes, sir.
Yes, we can.
Then we'll continue.
Yes.
Meanwhile, you please complete it. After that, we'll go for break.
write
Yes, sir.
see in the below circuit 0 1 becomes below circuit 0 1 becomes no 0 on top
0 1.
0 on top where no 0 on top where
Here no.
yeah 0
Yeah,
1
0
becomes
1 0.
1 0 right
1 1 sir.
sorry 1 1
1 1.
correct
Yeah.
now just show that becomes 1 1
This
for
will
the top
become 1, 1. Yes, sir.
okay
Okay, so like this, the second case which was 0 1, it will come to 1 1 in the first circuit, and in second circuit it is easy to see that the same output we have 1 1.
no but you show no so slowly you show why it comes to 1 1
Yeah, okay. So second case we have 0 here, 1 here. After Hadamard, 0 will be 0 plus ket 0 plus ket 1 by root 2, and this will be ket 0 minus ket 1 by root 2. So which is this case 1 by yeah, correct. So everywhere this should be 1 by root 2 square, 1 by root 2 square. It is in other words 1 by 2, correct. So here we actually have 0 plus 1 by root 2, and after this we will have 0 minus 1 by root 2. Now taking that root 2 square outside, we have 0 0 first state, 0 minus 1 the second state, 1 0 where is that state?
Last one.
1 0 the third one, and
That is, you are discussing about side 2.
yeah, this is after applying
After CNRC.
after CNRC, that is erased. Yeah, okay. Maybe I'll just erase this step. Anyway, we are not discussing that. So this is actually psi 1, and that psi 1 we can also write it as, 1 by 2 into 0 0 minus ket 0 1 plus ket 1 0 minus ket 1 1. Yeah, that is in psi 1. Now in psi 2, we have first qubit being the control one and second one being the target. Since the first qubit is 0 here, first two terms will not change, and next two qubits we have next to first qubit 1 0 will become 1 1 and 1 1 will become 1 0. So we Hello? Yeah. So here, after being careful with sign, we can do this rearrangement that we can see that 0 is the first term here in both the qubits. So we can take that 0 in some sense common. So ket 0 will be outside and we are left with ket 0 minus ket 1 plus here we have 1 common in the first place, so we can write it as ket 1 into ket 1 minus ket 0. Okay, but here if we want to apply Hadamard, it's better to have it the other way around, that minus should be to 1 and plus should be to 0. So we can as well take minus outside, I mean common, in like common. So we have 1 by 2, first term will be as it is. Now we are writing it as minus of ket 1 into ket 0 minus ket 1. Yeah. So now we can see that this is common anyway. So we can write it as ket 0 minus ket 1, and what will remain is ket 0 minus ket 1 here. And since we are applying Hadamard, it will be reverse direction. We know that this is nothing but ket 1 after applying Hadamard. So reverse way, this will go back to 1 and the second term will also go back to 1. So we get 1 1. Similar steps will follow for remaining 3 cases. Okay. Thank you.
So pi plus state, we know that that is an entangled state, no? Bell state, entangled state. How to show that? That is correct. So how to show that? It is impossible to write it as tensor product of So all of you remember now how does proof by contradiction work? Okay, just a minute. All of us know what is truth table for this. Correct, no? P implies Q is that is the truth table. Now, how to show that P implies Q is true? P implies Q is true. If you can look at the truth table of this, okay, no? Look at truth table of this, and then automatically you should be able to get idea, no? Okay, otherwise instead of directly explaining the truth table, I just give you scenario. So majority of the students, BTech students, say your parents might have promised some gift after you get good rank in whatever competitive examination that you took to get admission into, say BTech or BSc or whatever it may be. Okay. So one thing is they promise it's a gift, whatever you wanted. Now P is you writing on qualifying in that exam. Q is whatever they have promised, they are giving that. Now you got good rank in that exam, whatever promise they have given, whether their statement becomes true? Yes, they kept their promise. No, okay. The third one here, second one, you got rank, but they said no, to motivate you only. I said like we said like that. No, null, no mobile, nothing. Okay, that means whether promise is kept or not? No. Third case, student has not secured the rank which they expected or which was okay, but still they said no, still we are buying and giving it to you. Only thing is with the hope that in future at least you do something, or if you are not doing also fine. Okay. That time whether the promise is broken or not broken? No. What? If you get it, but without getting also they are giving, it's not correct, no problem, no. It is not violating, no. Okay. Now here you have not got, they also have not given, whether promise is broken? Not broken, no. That means the only case where it fails is getting rank, but they are not giving phone or whatever it may be promised. Now if you ensure that whenever a person gets rank, and their parents also definitely going to give whatever gift they have promised, that means the statement becomes true always. The other three cases we need not worry. Only the case where first one is true, second one if you give guarantee that second one also becomes true, then that is called direct proof. We assume that P is true, we show that Q is also true. That is called direct proof. There are different ways of proving this. Okay, no, based on this truth table only all the things we get. One is direct proof. In the direct proof, what is that we do? We assume that P is true and we show that Q is also true. Now we are going to do, say, proof by contradiction. We need this. What is proof by contradiction? What is proof by contradiction? We assume that given implication is not true. The negation of what is given is true. We assume that negation of P implies Q is true. Is true. Is true. Okay. What is P implies Q? We also, there is equivalent formula for that. P implies Q is also equivalent to negation P or Q. It is equivalent formula. Okay. Okay. Now by De Morgan's law, this becomes, it is same as P and negation Q. This entire thing is true. Is true. Okay. That means here what is the advantage? See, two things we have got as premises, no. In contradiction, more statements we get as to start with. That is the advantage. So P is true, but Q is false. When does it become true? P should be true. Negation Q also should be true. That means Q is false. P is true. P is true. Negation Q is true. That means Q is false. Then somehow you arrive at a contradiction. Is that okay? It may be contradicting with some well-known fact. Later, after some step, you get that 16 is greater than 205. That means it is a contradiction. Or you get a contradiction to your assumption that P is happening negation P. That is also one contradiction. Negation Q is happening Q. That is also a contradiction. Okay, different contradiction if you occur, then if you get, then we say that, oh, whatever we assumed is not correct. That means what is that we assumed? This is our assumption. This is not correct. Negation of what we assumed is correct. Negation of what we assumed is correct. That means this is correct. Negation of negation P is this. Oh, that means this is nothing but given statement is correct. That is the way we conclude, no? Now we are going to give, all of us know that that is entangled state, no, 10A. It's a Bell state, we know that it is entangled state. Now we are going to give a contradiction proof. Now sometimes if the statement is not of the form P implies Q, then how to prove that? It is only, say, root 2 is irrational. Is it of the form P implies Q? Not there, it is not of that form, no. Then what is that we do? So in contradiction, this is not if this form, then if it is only statement P, it's directly you take negation of P is true, then arrive at some contradiction. Then assume, then conclude that, oh, whatever we assumed is not correct, negation P is true is not correct, negation of negation P is correct, which is nothing but P is true. Okay. Now we are going to use that. Okay. Now by contradiction proof, by contradiction we assume that whatever is given to us, let us say this is state psi is, or pi plus only I can write, no, pi plus is 1 by root 2 ket 0 0 plus 1 by root 2 ket 1 1 is not entangled state, is not, or it is a product state, I can say, not entangled means is not entangled. That means what? If it is not entangled state, we should be able to write it as tensor product of two qubit state, no, quantum state. So let us say psi is one quantum state, let us alpha ket 0 plus beta ket 1 form. Okay, this is one. Another one is, let us say pi, this is gamma ket 0 plus delta ket 1. These are two states such that this pi plus we should be able to write it as tensor product of these two, no. It should happen, no? If it is not entangled state, there should exist two states, that is say psi and pi, such that pi plus is same as tensor product of the two. Is that okay? Okay. Now please calculate what is psi tensor pi, ket psi tensor ket pi. What is this value? alpha ket 0 plus beta ket 1 tensor with gamma ket 0 plus delta ket 1. What is this? We know that it is alpha ket 0 0 plus beta alpha gamma ket 0 0, no, alpha gamma ket 0 0, okay, plus alpha delta ket 0 1, is that okay, plus beta gamma ket 1 0, is that okay, plus beta delta ket 1 1. But we know that it is what, pi plus, it is what, 1 by root 2 ket 0 0 plus 1 by root 2 ket 1 1. Now from this you can complete, no? That means what is this value? This value must be equals to 0, no? Similarly, what is this value? This also should be equal to 0. If when does it become 0? Either alpha is, in this case, alpha is 0 or delta is 0 or both, no? Alpha is 0, beta are 0 or both. In that case it becomes 0. Here it is beta equals 0, beta is 0 or gamma is 0 or both. Is that okay? Now can you see any contradiction here? That is, if alpha equal to 0, this is 0, but we know that its value is 1 by root 2. For example, here beta equal to 0, then what happens? This also becomes 0. So it's a contradiction. We have got contradiction to the fact that it is equal to this. No, they are non-zero. Is that okay? Like that, whatever state is given, you can show that yes, it is entangled state. Not entangled, we can give it as a tensor product like this. The other one, you try whether is it entangled or not. What are the states? Then tell me, brother, what's the answer? Alpha equals to which one? 11 10b what? Okay, this is okay. Here this values you are giving. Okay, okay. Here also assume that we are taking alpha like this. Now you tell what are alpha and beta values. Alpha, beta, gamma, delta. Alpha is Okay, or directly you can 1 by alpha is 1. Now, what I am saying is, he said one state is this, one is this. First of all, is this correct? So 1 by root 2, na? 1 by root 2. So what is saying is, now it is 1 by root 2 ket 0, psi is 1 by root 2, 1 by root 2, that is 1 by root 2 ket 0 plus 1 by root 2 ket 1. Then what is pi? Minus 1 by root 2, na? That is not correct. 1 by root 6 for 0 0. If you fix this 1 by root 2, definitely you have to do this only, no brother, because 1 by root 6 ket 0 0. Then you tell what are alpha beta? Alpha beta 1 by root 3, na? So okay, let us change it like this. He is giving something. Alpha beta gamma. Gamma is 1 by root 2, delta minus 1. Is this is that you have some answer? That's what I am saying. That is alpha beta is 1 by root 2. Next gamma delta. Minus square root of 3. 1 by 3, 2 by 3. That is okay. I think it's to be correct. 1 by okay. Let us. This is 1 by root 2, 1 by root 2. Here 1 by root 3, root 2 by root. Sorry, something like this. Is this? So whether for this 10b is that correct or not? Tensor product of given two states, is it same as that or not? 1 by root 2, 1 by root 3, 1 by root 6, okay. 1 by root 3, 0, 1, that is also okay. 1 by, are you following? 1 by root 2, 1, 1 by root 3, 0, 1 by root 6, 1, 0, 1 by root 6, 1, 0, that is also correct. 1 by root 2, 1, 2 by minus root 2 by, that is minus 1 by root 3, 1, 1, that is also correct. That is also 1 by root 2, 1 by root 2, that means that is a valid qubit quantum state. This is 1 by root 3, 1 by 3, and that is 2 by 3, that is also correct. I think this is answer. Is there any? Okay, this last question, 11th question we take and then stop. Remind or to this I will post it in that to that drive. Okay, you may practice 3 or 4 problems, whatever remaining. Okay, is it clear? That is general procedure. But anyhow we need to, it is like a solving equations only. No, finally we get 4 equations. Complicated, correct, correct. No, it is only to give you how to do it. That's that way not. Sir, that it has to satisfy now, sir, that condition. Okay, last 11th one, please tell me answer once again. That's all. This is control, not gate. So both are 1, 1. So finally answer is 1, 1, 1. What is the other name for this gate? This operation? See, control, not. Okay. Okay, we stop here if there are any questions.